everyone, this is Mrs. Jackson, and this is Chapter 2, Section 3, Part 1. And in this first video, in Section 3, we're going to be talking about how to factor a quadratic expression and factor a quadratic equation and using those factors to solve that equation. So this should be review for you. I know that you've done this in Algebra 1, but we are going to be doing quite a bit of factoring for the rest of this chapter at least. And so I wanted to review it. Okay, so the first thing to note is why would we ever want to solve a quadratic equation? What are we solving for? And the answer there is we're actually solving for the x-intercepts. We're solving for where that quadratic function is intersecting the x-axis. And as you know, sometimes we may get one solution for x. More likely, we'll have two values that we solve for x with a quadratic. And sometimes we may have no solutions. But those x-intercepts are called the zeros, predominantly in our textbook. So when you see the word zeros in the textbook, it's talking about the x-intercepts. You'll also hear another common phrase called the roots. That's something more from my background. I would call them the roots. Some textbooks would call those x-intercepts the roots. Okay, so I want to review just how we can factor a quadratic expression. But before I do so, let's talk about what are factors. So in something simple like 2 times 5, the 2 and the 5 that are multiplying each other, those are called factors. And they're actually factors of the number 10. When they multiply each other, the product is the result. In other words, 10 is the product. That's the result of the action or verb multiply. So factors are really division. It's the inverse operation of multiplication. When we split something out into its factors, we're kind of dividing and we're seeing what are the things that make up that product. And we can extend that thought process to algebraic expressions, which is really what we're going to be doing here with factoring quadratics. We're going to end up with expressions that multiply each other. And when we move forward into later chapters, we're going to be doing that extensively with full-up polynomial expressions or equations. Okay, so if an equation can be factored, then we can use something called the zero product property to easily solve for the zeros or easily solve for the values of x in that function. For example, if I already have a quadratic that's factored, and this is a quadratic, 2x minus 1 times 3x plus 2 equals 0. If two things are multiplying each other and getting 0 out, then we know that one or both of those things must equal 0. So we can put 2x minus 1 equal to 0 and 3x plus 2 equal to 0. The process by which I just did that is using the zero product property. Once we have these two simple single variable equations left over, then it's quite easy to solve. And you can see here that x equals positive 1/2 and x equals negative 2/3. Just to take a moment here and show you that this factored form certainly is a quadratic. Remember, and I'm going to zoom in here, remember that when you multiply two binomials together, you will almost always, not always, but almost always, get a trinomial out. Okay, so everything has to see that distributive property. So 2x times 3x is 6x squared. 2x times a positive 2 is a positive 4x. Negative 1 times a positive 3x is negative 3x. And negative 1 times a positive 2 is a negative 2. And you can see here, if I combine my like terms, that this simplifies to 6x squared plus x minus 2. Notice that this first term here, 6x squared, is the product of these first two terms in the binomial. And notice that this negative 2 here is the product of the constants in the two binomials. So the process here of factoring and going in reverse, taking something that looks like this and getting back to these binomials, is all about finding what these two first terms are and these two terms are that are going to give you this middle term here. So that's the technique that I'm about to teach you. Okay, so first thing in this column here, notice that we have a quadratic, we've got the x squared term, but we do not have an equation. This is an expression, and there's nothing to solve here. Okay, there's no values of x we can solve. We can only do that if we have an equation. So when we have an expression like this, the only thing we can do is find its factors, like take the number 10 and find its factors are 2 and 5. So right here, with this quadratic, we're going to focus on splitting this trinomial back into the product of two binomials. Okay, now how do we do that? First things first, once you're in descending order of exponents, then you identify your A, your B, and your C. And I like to make myself a little table. So I know some of you might have been taught to use some kind of X. I don't recommend that, so I'm going to show you what I do. A equals C. The first thing we're going to do is find out what the product is of A and C. And whoops, I didn't write down what my C is. C equals 21. All right, so 2 times 21 is 42. And then in the second column, I'm going to write what my B is. So what we're looking for is two numbers that multiply to give you 42, positive 42, and sum to give you 13. And I know probably right off the top of your head you can find those two numbers, but sometimes it can be a little bit elusive, and so it might turn into a little bit of a trial and error process. So I'm going to go to great lengths to show you that trial and error process. And I know you don't need to do this for the most part. So 1 times 42 is 42, and they sum to 43. Then you go up to 2, and you can see 42 is divisible by 3. So I'm going to go 1, 4, and that sums to 17. And is it divisible by 4? No. Is it divisible by 5? No. But it is divisible by 6. And at that point, we've achieved what we're looking for, which is that 13, B equals 13. Okay, so once we have those two numbers, then we can start setting up something called factoring by grouping. So our first term is our first term, 2x squared. I'm going to rewrite my 13x as the sum of 6x, where these numbers come from, 6x and 7x. So that's my task that I'm going to do. And it doesn't matter if I say plus 6x plus 7x, or if I reverse those numbers and say 7x first plus 6x. It doesn't matter the order. But our task is to rewrite that 13x. That's what we did. And now we're going to use a technique called factor by grouping. So factor by grouping is going to take the first two terms and the second two terms separately. So what can be taken out of both of these first two terms? Well, we can certainly take out an x, and we can take out a 2. And what we're doing here is using the distributive property in reverse, so which is division. So 2x squared divided by 2x would be an x, and 6x divided by 2x would be a 3. So you can see if you did the distributive property back, you'd end up right back with the 2x squared plus 6x. Okay, now what can be taken out of the next two terms? Both the 7x and the 21 can be evenly divided by the number 7. And so I'm going to take that positive 7 out, and I will have an x left and a 3 left. And so if all went well with your factoring process, Your hope is that you're going to end up with exactly the same factor inside those parentheses, x plus 3, x plus 3. And the distributive property allows us to bring the 2x plus 7 together now because they're both multiplying the same yellow expression. So the distributive property will say that I can bring that 2x plus 7 together, and it's multiplying the x plus 3. Now I could just as easily write this as x plus 3 times 2x plus 7. It doesn't matter the order. 2 times 3 is the same thing as 3 times 2. That's called the commutative property of multiplication. So the order doesn't matter, but we've just broken down this quadratic here, this trinomial, into its two distinct factors. At this point, nothing left for us to do. We cannot solve for x. We do not have an equation. So we've broken it down into its factors. Now, if we do have an equation to solve, which more than likely we will, then the main thing that we're trying to solve for is those x-intercepts. Now, those x-intercepts happen all along the x-axis where y equals 0. So we're actually, our goal is to try and put our, let's see, I'm not going to do that. I'll just use more generically. Ax squared plus bx plus c equals our output, and we're actually going to solve for our output when y equals 0. So we really want 0 on one side of the equal sign because that's where the x-intercepts are going to happen. Consequently, in this very first problem, we have a -5 on the right-hand side, and we need to move that over to the left side. So we're going to use our inverse operation, and we're going to add that to its only like term over here on the left. So we're going to end up with 3x squared plus 2x minus 16 equals 0. And that's what we want. It's this 0 here that's going to allow us to get those x-intercepts. Now at this point, I should have said this in the last example, you should try to factor out something out of these constants if you can. The coefficient, if you can factor something out of these coefficients and the constant, you should. It'll just make your table a little bit easier. We can't in this example, but you should always try if you can. All right, so let's identify our A, B, and C. We have A equal 3, B equal 2, and C equals -16. So I'm going to make my little table here. And my A times C equals -48. And our B equals a +2. So I think many of you, without making a long table, can probably figure out what those two factors are. But if you can't, you'll take the same approach that I just did, that step by step. First start with a number 1, number 2, number 3, etc. But hopefully you can see that a +8 and a -6 multiplied together will give you -48, and they sum together to give you a +2. All right, so our task here that we are using is to rewrite this 2x with this a sum of 8x minus 6x. And so again, it doesn't matter what order you put those in. I will go ahead. I think because the coefficient 3 has something in common with a -6, it might be more convenient to put the -6x first, but it does not matter. As I said, you will end up with the same exact result. It just makes it a little bit more convenient. So we've got factor by grouping set up. What can I take out of the first two terms evenly? I can take out a 3, and I can take out an x. And when doing so, I'll end up with an x and a -2 left over. And what can I take out of the next two terms evenly? I can take out an 8. And what I have left over would be an x and a -2. And now I do have an equation, so I'm going to keep that equation going. Actually, that brings up a good point. Don't lose your equation. Keep putting that equal to 0 and carrying that down. Okay, so I have, what I'm looking for here is the same exact factor, x minus 2, x minus 2. Distributive property now allows me to bring the 3x plus 8 together because each of those terms are multiplying the same factor. And now I'm going to use my zero product property rule, which says that if I have two things multiplying each other and getting 0 out, one or both of those must be equal to 0. So you're going to set independently each of these equal to 0, and they end up being very easy equations to solve. So I have x equals 2, and I have, I'm just going to skip the inverse operations in the interest of time. I have x equal negative 8/3. Go ahead and leave it. Don't even try to turn that into a mixed fraction. Leave it as an improper fraction. So what's happening here? We have a quadratic that is upward facing. You can see it's got a positive a here. It's got some stretch, so it's tall and skinny. It's upward facing, and it's going through the x-axis at x equals 2, and it's going through the x-axis at x equals negative 2 and 2/3. And somewhere in between, in fact, exactly in between those two, we would call that the midpoint in between those two, would be our axis of symmetry. Okay, so far in this video, we've looked at or tried to review and reinforce how to factor a quadratic expression. One word of caution here is that not all quadratic equations or quadratic expressions can be factored. We're going to be focused on that quite a bit going forward, but just to put a pin on that, sometimes it will not be factorable because the solutions are irrational. In other words, your solution may be like the square root of a non-perfect square. That's going to be tough to factor. Or the solutions may not be simple fractions that terminate. Maybe they do not terminate, although sometimes you can factor those. Like you could get 1/3, for instance, pretty easily. But more likely, if it's not factorable, there may be no solutions at all. So that's something that we're going to have to understand in a future section. So more to come on that. But to finish out this section in this video, I would like to show you how to factor a quadratic and actually use those x-intercepts, those zeros as the textbook calls them, to graph that function. So as we already mentioned in previous videos, when we're in the standard form, it's tough to graph that function. But sometimes you can, just knowing the zeros. Okay, so let's take a look at how we can approach this. So we have a function, f of x equals 2x squared plus 12x plus 10. That's just y equals 2x squared plus 12x plus 10. And if we're going to try to find those x-intercepts, then we're going to set y equal to 0. That all along that x-axis, y equals 0. And so we have this quadratic that we're trying to solve. And here in this example, we can factor out the 2. There's a 2 that can be factored out of every term. So I'm going to go ahead and do that. And we end up with 2 factors so far. Now that 2 up front definitely has an impact on the graph. It's the stretch, that's A. And this has a stretch factor of 2, so it'll be taller and skinnier than the parent function. However, for the purposes of finding the x-intercepts, I could divide both sides of this equation by 2, and the 2 kind of goes away. So for the x-intercepts, I can ignore the 2 for right now, and I'll just keep carrying it though. But hopefully you can see our A equals 1, our B equals 2, our B equals 6, and our C equals 5. So if we look at AC equals 1 times 5, 5, and we're looking for a B of 6. So hopefully you can see right away that we're looking for the 1 and the 5. Those are the only factors of 5. And so I can put my x squared plus, I'll say 1x here, plus the 5x here, plus 5. I'm replacing that 6x with 1x plus 5, and I'm going to use my factor by grouping technique, and I'm going to take out an x out of the first two terms, and I'm going to take out 5 out of the next two terms. And if everything goes well with your factoring by grouping process, then you have the same factor here, x plus 1, x plus 1. And so ultimately I have 2 out front here times x plus 5 times x plus 1. And I've broken down now my quadratic function into 3 factors, 2, x plus 5, and x plus 1. If I multiply this all back together, then I'm going to end up right back where I started from with a 2x squared plus 12x plus 10. Okay, but now my process of finding those x-intercepts becomes pretty easy. I have x equals negative 5, and I have x equals negative 1. Okay, so what can we do with that information? Let's also first find the y-intercept while we're at it. The y-intercept, of course, is when x equals 0. And so when we plug in x equals 0 into our function, then y is going to equal whatever that constant is, c. So our y-intercept is always going to equal c. And in our case, it's going to be positive 10. And what else can we look at? Our line of symmetry. Our line of symmetry is going to go through our vertex, and our vertex is going to be exactly in the middle because of that symmetry between negative 5 and negative 1. So if we graph those points over here, negative 5 and negative 1, I'll get negative 5 here and negative 1 here. Then hopefully you can see that our graph is going to be symmetrical right along x equals negative 3. And it is upward facing because our leading coefficient is a positive 2. So our vertex is somewhere here along this green dashed line that I just drew, because the vertex is in the middle. So if we take a look at that, the easiest way to get the vertex is to plug in our x equals negative 3. So I'll write down vertex. Vertex is, of course, h comma k, x and a y. Our x, we can see on that green line, our x equals negative 3. So I can plug that into my function and solve for exactly what my corresponding output is, or k. 2 times a negative 3 squared plus 12 times a negative 3 plus 10. We've got 9 times 2 is 18, minus 36 plus 10. That's negative 18 plus 10, so it's going to be a negative 8. So our vertex then is at negative 3, negative 8. So I can find where that location is and use that as a point, negative 3, negative 8. And our, let me see, that's a little messy. Our y-intercept, we already said, is up at positive 10. And you can see with the symmetry, you can see that y equals 10 is 3 over from the green line. So I can go 3 right from the green line. So I could go 3 left from the green line. And because of symmetry here, I know I'll also be at positive 10 there. And so that's a good set of 5 points that I can use to sketch out my quadratic function. You can see it's definitely tall and skinny with that stretch of 2. All right, so in this video, we reinforced or reviewed how to factor a quadratic expression as well as an equation. And then we further took that to a graph and used those x-intercepts, or the zeros as the textbook calls them, to actually sketch out the quadratic function from that information. Okay, I hope this video helps. Thanks for listening.